Nvidia's CES 2026 was, well, mostly around robots and AI agents, but the most important of them all was the Rubin platform that released 6 different chips. And you might be wondering, why does this release matter to me at all? When we look at CES trade shows like this, what we're really talking about is technology that's often ahead of early adopters. For example, the Rubin platform is currently in full production, which means starting the second half of 2026 is when their partners will be able to get their hands on these, which are most likely companies like OpenAI and CoreWeave. But what we really want to know is why. Why does this matter? Today, we're going to look at Nvidia's most recent Rubin platform and what this tells us about the macro trend in the AI industry overall. Welcome to Caleb Writes Code, where every second counts. Let's start by first breaking down the industry in this way, starting from more traditional AI applications like ChatGPT, Gemini, and Grok that we use on a daily basis, and they all use large language models. And frontier labs like OpenAI, xAI, Anthropic, and Google all need access to graphics cards. Meanwhile, we also have a more complicated extension of LLMs like AI agents like Claude Code, Cursor, or even custom chatbots that use RAG. These are agentic applications that really extend the LLM's capabilities. And AI agents that use LLMs also rely on graphics cards and a good CPU to orchestrate the entire process. And finally, we have data centers that houses these graphics cards, and they need constant source of energy. So when we talk about the Rubin platform from Nvidia CES 2026, it's this layer that we're talking about. And you might be thinking, well, this is just a small piece in the system. But this really carries a bigger downstream effect in the entire AI industry, and here's why. While AI researchers tend to focus more on the theory behind LLMs and other types of AI model architectures, when it comes to actually training those models and running those models for inference, the viability of their research is somewhat bound by what's higher in the stack, which is graphics cards that actually determine the speed and efficiency of training those models and actually running those models at inference. For example, 2025 was the year when mixture of expert architecture was really adopted as the industry standard. Notably, Qwen 3, DeepSeek R1, Llama 4 Maverick, and Kimi K2 Thinking are all examples of mixture of expert models that we saw in 2025. And as much as in theory, a mixture of experts essentially allows higher token efficiency, the underlying graphics cards also need to support this in both training and inference, especially if experts are distributed across GPUs. In other words, if you spread the model across multiple GPUs and multiple nodes, and you start to factor in routing and communication and synchronizations all together, you start to get into the bottleneck being more in the system level overhead as opposed to the actual speed of the graphic cards itself. You could also say the same thing about RAG, where even though RAG in theory could work well in retrieving information in context, you also need the underlying system to support them, since RAG especially rely on external storage that's coordinated by CPU, which means that each delegation going from GPU to CPU to storage over a network, you have to pay the tax in the form of latency, bandwidth, and synchronizations overhead. As you can see, we have this strange dependency between what Nvidia releases and the AI researchers, where hardware and software meet both in the forefront. So when we look at Nvidia's release of their Vera CPU, Rubin GPU, NVLink 6 switch, Connect X9 SuperNIC, Bluefield 4 DPU, Spectrum 6 Ethernet switch, all seem to point to 2026 being the year of agents and robots. In other words, Nvidia is doubling down on the importance of supporting their partners in inference and not just in training, since 2026 is when people are going to start expecting AI to be more than just theory, but an actual value add to their lives. And we saw an indication of Nvidia's growing attention in the inference market by their recent quote-unquote acquisition of Grok's talent and IP for their fast inference cards. The performance of the Rubin GPU did not disappoint, where their NVFP4 training is expected to be 35 petaflops, which is 3.5 times faster than their previous Blackwell chips, and inference is expected to be 50 petaflops, which is 5 times Blackwell chips. Not to mention, they also increased their NVLink bandwidth to 3.6 terabytes per second and HBM4 bandwidth to 22 terabytes per second. What all of this means is that Nvidia is kicking off the year 2026 by revealing a more concrete plan for their Rubin platform, along with myriads of open models like the Nemotron for agentic RAG and speech are setting the expectation of how the rest of the year might look like, which is this. We're moving away from simple generative AI, but we're now moving into agentic and robotics, where both training and inference needs to be a lot faster because the industry is maturing into actually applying AI into production. In other words, as more neoclouds and hyperscalers start to get their hands on Nvidia's Vera Rubin NVL72, what we can expect as users all the way to the left is significant improvement in SLA in not only tokens per second per user, but also tokens per second per GPU. And if you think about it in the context of AI competition between US and China, our ability to deliver on this very metric of token speed and efficiency is really going to start separate us as a dominant player, since American neoclouds and American hyperscalers will get their hands on these first. And if AI does unleash a huge economical value that all rely on fast inference, that realized value in our economy will be that much better than China, even if China is milliseconds away when it comes to AI research, because value will be gained faster and wider just by having better hardware to run these AI models more efficiently.